Welcome back to another one of my applications of differentiation videos. This will be focused on the mean value theorem, and this is the 5th episode, and I'll be talking about, I'll be using a sine function in this one. So first, when we're discussing any sort of mean value theorems where if we should use it, we have to pass these three criteria, which is if it's continuous within the closed interval, if it's differentiable on the open interval, and if the function of A doesn't equal the function of B, then you can use a mean value theorem, which is basically using this formula right here to find the point at which the slope at a point is equal to the slope of the secant line that passes through the 2 points. Okay, so hopefully you all know what a sine function is, but I'll draw it anyway. So a sine function basically comes up, goes down, comes up again, it goes down again, and it goes on forever. But we don't want to go on forever. We are looking at what we're looking at is the function of sine 2x within the domain of, I'm using a fraction, 2 over 5 and 3. Okay, so that's going to look like, well, when you look at a sine function, usually when you have sine x, it goes all the way up and all the way, it goes does one full revolution to here in 2 pi. But because I've got 2x, it essentially does twice as many twice as many revolutions in 2 pi, so it does them twice as fast. So instead of this being 2 pi, it's basically moved this one to be 2 pi, and this one is pi. So it does, yeah, that's it. Because I put 2x there, it basically does twice as many oscillations. Okay, so that means halfway is pi over 2. Okay, but we won't worry about this here. We don't care about this because our values are between 3 and 2 over 5. 2 over 5 is about here, and 3 is about here, just below, because pi is like 3.14, I think 159 or something, but yeah, a 3 is just before pi. So what we're looking for is this, which will, I think it's 2 over 5 is about here. So it should pass through like that. There we go. Hopefully that's the line that's passing through. Okay? And the slope of that line is equal to this half, and this part will help us find the two other points, which should be roughly about here and here, where the tangent that passes over those 2 points is the same as the slope of the tangent line is the same as this line that passes through. Okay, so this is parallel to that, and that is parallel to that. Anyway, let's get on to it. So first, this will be this is our A and this is our B value. So A is equal to 2 on 5. Therefore, if we sub that into the function, and we have a function of A, that now equals approximately 0.717, because it gives me a giant decimal that I don't want to work with, so I'm just going to write approximately that. And B is equal to 3, so the function of B is equal to approximately negative 0.279. And just remember, there's rough rounding in this. There's not. I'm not going to end up with the result that's 100% accurate. It's just going to be showing you how to do it, and if you want to be picky or whatnot, you can. But this is just rough calculations. rough numbers. Okay, so, and remember, if you're doing this, calculating this, you might not get these values. It might have a little spit of something else, but that's because you need radians. You need to set your calculator to radians to calculate these. Anyway, so now we have this. Now we're going to replace x with c to find the function of c, which will be sine 2c. And now we derive that to find the derivative of f of c. The derivative of sine is cosine, and the inside stays the same, and then you multiply it by the derivative of the inside, which is 2, so I'm just going to put the 2 out the front and save the trouble. So it's cosine 2c, and then you multiply by the derivative of the inside, which is 2. And that there is our derivative of c. So, the formula, derivative of f of c equals fb minus f of a over b minus a. So, we sub this in and we get 2 cos 2c equals f of b, which is roughly negative 0.279, minus f of a, which is 0.717 roughly, and b is 3 minus a, which is 2 on 5. And what we end up getting on this side is negative 0.383, and this side's 2 cos 2c. Now we divide both sides by 2 and we get cos 2c equals negative 0.192, because we divide both sides by 2, so that'll cancel the 2 and divide this by 2. We get that. And then to get the cosine on the other side, we multiply by the inverse, so we get 2c equals cos, or the inverse of cosine, negative 0.192. Okay, and when we divide both sides by 2, c equals approximately 0.882. Because what I've done there is I've just skipped a step, so I've done inverse cosine of that, and then with that value I've divided that by 2, and I've gotten this number because I isolated c. Now, if you remember, if I can find it, what the function looked like. If you can remember, there's 2 values here, but this only gives us 1, and this is the trick with sine functions. Okay, now the thing is that that's 0.82 from 0, so it's gone 0.882. Okay, and that's the point there. That's C1. We still need to find C2. Okay, so it hasn't gone from this point or anything. It's gone from 0, and that's 0.882 in the positive x direction. Now, because I have a little trick with these. Some people do it differently, but with sine functions, it's in symmetry. Everything is in perfect symmetry, basically. So if you start over here and you start over here, they have the same slope from 0 and pi. Using this function, they have the same slope. So as you go around, they have the same slope, and then they come to 0, and then they have the same slope here, and that same slope is equal to the middle one. But that way, if it takes 0.882 to have a slope of that, then to have a slope of this, if you come negative 0.882, if you come 0.882 backwards, you will get that same point over here. Well, not the same point, but you'll end up with the same slope because they're in symmetry. So that there, this point here, C2, is basically if you went back 0.882. Okay, so this is 0.882 from 0, and therefore that's C1, and C2 would be roughly pi minus 0.882. Okay, that's because it's going in the negative direction. This is the way I do it. It's going in the negative direction, 0.882. So if you add pi, it will give you the distance from 0, and that's the distance you want. Okay? So if we have a look at that, pi minus 0.882, and that equals approximately 2.26. That makes sense. If you bring this function up on a computer and you have a look at it, you'll see that the slope at this point, or 0.882, the slope will be the same at the slope of this point, which is at 2.26 radians. Okay, now I hope that made sense. I hope it didn't sound too complicated, but basically where I was going with is that it's in perfect symmetry. So when this goes up, this comes down. They have, at these points they're flat, they have the gradient of 0, and then they start coming down. So therefore, if this at 0.882, it's gone up and left there, and this has gone, that means this must have gone 0.882 in the negative direction to end up with the slope. So that's how I think about it. It might not be helpful for you, but it's a different way of thinking about things, and there's no problem with that. Anyway, so I hope this video helped you. Those were the two C values, that and that. Now, yeah, so thanks for watching. I hope you learned something, and I hope you have a good day.